Hey everybody, I hope you're having a great day. Today, we're gonna follow up on that mapping video that I hope you've already watched. If not, go check it out now. But for those of you who did, we're gonna move a little bit forward on that, and we're gonna specifically look at how do I deal with symmetrical forms, and some forms that maybe aren't quite symmetrical. I'm gonna help you learn how to figure that out and to break it down and map those bad boys. Are you ready to go play? I think you are. Let's go.
Well, I look at it myself as the beginning, really, of an exploration. That's the reason we're exploring. You don't know what you'll run into on an exploration. What the sky looks like, what the stars look like. Do they still twinkle, or are they a steady light when you get outside the atmosphere?
In my previous video on mapping, I introduced the concept of comparing intersections and edges with other intersections and edges that exist in the grouping that we're wanting to deal with. That video dealt with rectilinear forms, and that means straight line edge. But what happens if we don't have all straight edge forms? What if I have forms that have curves or irregular edges? How do I deal with that? Well, basically we're going to deal with it the same way as we did before. We're going to find high, low, left, right positions. We're going to find boundaries of the overall forms, but also boundaries of each of the individual forms and how those relate to each other. From there, we'll find the specific movements of the edges of those forms. Now, there'll be curves, but we'll find those curves through a series of angles that will help us avoid what I call the wet spaghetti noodle curve, a nondescript curve that doesn't have structure. So just like last time, we're going to first begin by finding the outer boundaries of the grouping by taking a horizontal or a vertical stick and running it up against the grouping until we hit the first edge or intersection that we encounter. We're also going to decide on what we'd like to use as a unit of comparison for what we're looking at, our schmedium, if you will. In my example here, you can see that I've designated the edges of the forms, the grouping, that I want to make sure is in my composition, and that's indicated by the blue box. My schmedium, my unit of comparison, I've chosen the height of the cardboard box. The AB position of those intersections is actually on that boundary. So to help you see my schmedium a little better, I just moved it to the right. Then, using the approach that we used in the previous mapping video, you'll want to transfer and translate onto your paper your unit of comparison, your paper schmedium, and place your boundaries where you want them to be in your composition. From here, you'll notice that I've placed the red intersections, the AB, of two edges. One is the schmedium on the far left, and the other is the front of the table with the A intersection on the left and the B on the right. And of course, you'll move through that AB. But beyond that, we're going to let those hang for a little while, and instead we're going to focus on finding the outer boundaries of the other forms that are within the composition. Think of it as subdividing your initial bunks or boundaries with smaller bunks or boundaries. And you'll compare those to each other in terms of their high, low, left, right, and how those compare to each other in terms of placement, as well as how far they go up or down, left or right, within the boundaries overall. I'm doing this on each individual form by bringing down the horizontal stick to hit the topmost part, or up from the bottom to hit the bottommost part. Also the left-right with a vertical stick. Same as when I find the overall grouping, but now just on the individual forms. You'll notice that the pink line that is around the green bottle, the green line that's around the yellow bottle, and the orange line that's around the bottle to the right. Each of those I've extended so that I can see where they hit on each other's heights to have a better sense of where they actually go. And I'm going to move those around until I feel strongly that I have placed them as best I can. And I've found those boundary placements with some confidence. Once I've located those boundaries of forms within the overall composition, I'm going to further subdivide those. I'm going to find the specific movements of each form. We'll start with the bottle that's on the far right. You'll see here that I've broken that down. Essentially, I started by creating a central vertical axis because this is a symmetrical form. And a symmetrical form means that if you were to fold it in half left to right, it would be a mirror image on each side. That's really great to know because if we recognize this and we use that central guideline, it makes sure for us that we find the placements in a way that's not wonky, that's not inaccurate. We place intersections, we find intersections that are created by a change of direction. So you'll notice the guidelines, in addition to that central vertical axis, mark the high and low position and the left-right position within the boundaries of the form. The thing about the symmetrical form is whatever I find on one side needs to happen exactly in a mirror position on the other side of that central vertical axis. By being aware of this, we can make sure that when we're dealing with a symmetrical form, our translation will end up being also symmetrical. It'll be far more accurate. And when you're translating these relationships to your paper, you want to make extensive use of guidelines on your paper to make sure they go where they're supposed to go. These yellow lines are actually lines that will be on your paper. And if you find yourself being reluctant about using those guidelines because somehow it makes your drawing more messy, I would say, listen, you need to redefine what you're doing here because construction lines, lines that help you find better, they're the history and record of your process. And that's what this is about. It's not about making a pretty product. It's about finding truth. It's about finding things as you see them as best you can. And the history of that, those guidelines, those making new decision placements as well, they're all vital, they are all vibrant, and they are all a record of your mind at work as you are contemplating, considering, and finding what is in front of you. And that is one of the beautiful things about drawing and painting. It contains the history of its own making. It shows the decisions you've made. It shows you thinking and contemplating. If you want a perfect image, I suggest you try photography. It does that really well. But this process of drawing and painting, it gives us something beyond just an image. And that includes the struggle of trying to find understanding. And there's something vulnerable and human that's embedded in that process. And I would ask for you to embrace that. So, moving on to the other symmetrical form, I just wanted to address it as if, for a moment, different than the image that I gave you, you're seeing it more from above. So the process of the more simplistic bottle that I just gave you is still at play. You're still using the central vertical axis and you're still finding high, low, left, right positions that are finding changes of direction of form. But here we have an ellipse that we need to find as well. You'll notice that I find the top, bottom, left, and right of that ellipse within the form. That creates a rectangle. That rectangle is in contact with that ellipse in 4 places. Those 4 places are exactly in the center of each of those edges. That's because this ellipse is parallel to the ground plane. We're going to mark that, and you can see that I did this with the yellow line. Once we've done that, we're going to go above this on our paper once we've established that translation, and we'll move our hand in either a clockwise or counterclockwise direction until we feel like, yes, I am moving in an elliptical movement around those 4 intersections. At that point, I'm going to gently lean into the paper, maintaining that momentum, and I will accumulate lightly that ellipse. I won't try to draw an ellipse because that's sure as heck going to end up wonky. So we want to record the body movement that we establish by moving over those 4 intersections. Here with this bowl and this bowling ball, we can see the same process of finding an ellipse. You can see here with the bowl, and I found the high, low, left, right in the green. Also, you'll find a similar way of finding a sphere. A sphere, translated to 2 dimensions, becomes a circle, in which case the height and width of that bowling ball will be exactly the same. Then we're going to establish, once again, the point that these forms touch those boundaries, which exist exactly in the center of each of those edges. And again, set up a movement above those on the translation that we've made on our paper, and gently record an accumulation of that movement lightly. That will give us a far more accurate circle and or ellipse than if we try to draw one in one shot. Simply said, we're trying to find an average of an ellipse or a circular movement instead of trying to make an ellipse or make a circle. It works better. So coming back to this more complex symmetrical form, you can see that I've broken down the high, low, left, right placements of changes of direction that were the most important. And once again, when we're translating these relationships to our paper, we want to make extensive use of those guidelines and of those intersection placements. And as we move them around, we find them more accurately. You'll notice also that everything's straight line. There are no curved lines here. And yet the accumulation of these angles do imply a specific kind of curve that's giving us a clear description of how the edges of this particular and unique form are moving. So let's take a look at another form that you're going to be including in this grouping, in this still life. It's not terribly complex. It's fairly simple, and yet it's not symmetrical. And it's got curves. It's not perfectly rectilinear. So how do I go about finding these relationships? Well, after establishing the boundaries of this form, we're going to take our stick and we're going to move it left and right to compare the left-right distances relative to the width of the form and to each other. You can take one distance and compare it to another in order to better find those. But also, if you have other forms and intersections that exist in the rest of the grouping, you can take those out, extend them, and compare them to those as another way of finding them as accurately as possible. And as always, we're finding two things about each intersection, not only where they exist left-right, but where they are high-low. And here we're comparing those high-low distances relative with the height of the form and with each other. Again, just like before, I can extend those out to other forms to compare where these exist relative to other established intersections elsewhere in the grouping. And translating those to the paper, it's gonna look maybe something like this when we have all our guidelines down. Those are gonna be helpful. Those are gonna give us what we need to move into this next phase where we move through the A-B intersections that are connected. In these instances, some of them are at angles, and we want to make sure we don't get lost and that we're paying attention to who is connected to whom. Also, here again, you'll notice that I'm not drawing loopy curves. I'm finding a series of angles, and we understand what those curves have to be doing specifically because of these changes of direction and the angles they create. Again, it's about finding specific movement through these angles. And remember, if you're at a 3/4 view looking down on this form, you have an ellipse and you know how to find that. You find the high, low, left, right, find the place that it touches exactly in the center on all four sides, and accumulate that ellipse. So coming back to our grouping once more, let's take a look at that green bottle on the upper left-hand side. As I said, we're going to find curves through the use of angles, and those angles are determined by the change of direction of that form. However, you'll notice that in the handle, it's an ellipse, but it's not parallel to the ground plane. It is at an angle. So how do we deal with that? Obviously, it will be an ellipse, or more specifically, two ellipses. We'll find the outer one first. So you'll see that where I have those red arrows, that becomes the lowest point and the highest point of that ellipse. And they're offset. The lower bottom point is to the left, and the upper point is to the right. And you can see that that offset continued on with the blue dotted line. So we find the high and the low of that ellipse, and I have it here with the yellow lines, and we find that the same way we find any other height. The left-right position of the bottom and the top placement of where it touches those yellow lines, we need to find that distance, that left-right placement of those intersections as demonstrated by the dotted blue lines. Then we'll find the left-right position of that large ellipse, the boundaries of it. And you'll notice, though, in this instance, it won't touch exactly in the center. We want to plot the point that they touch the left and right boundary. It's good to know that the distance up from the lower yellow line on the left will be the same as the distance down from the upper yellow boundary to the point that it touches on the right. And that gives us four intersections that we can hover above, creating an elliptical movement, and slowly move in and record that larger ellipse. As always, we erase our guidelines. We'll still be able to see the ghosts of them, and that's great. There's nothing wrong with that. It's what I was talking about earlier. It shows the history of its construction. So what we're left with is specific placement. We've mapped these forms, and we've mapped the specific movements that exist on the edges. You'll notice here that I've done a rudimentary attempt to create line weight change near far, heavier line weight closer, and reducing that line weight, or that thickness of line, as we move back. And that's all we need to map these forms. If we're painting, it's a great foundation to move forward with other kinds of analysis on. And for drawing, it gives us a way of thinking and examining curves so that when we do use something other than straight line only, we are able to look for and find specific curves that aren't like limp spaghetti. And we retain the specific relationships and structure of the forms that we see. And hey, that's it. All you have to remember is you're trying to find a set of relationships, not trying to make a picture of objects. The objects, those will be understandable from the relationships that we find. It'll end up looking like stuff. You just gotta trust it. Remember, you're trying to find the set of relationships, not make a picture of a set of objects. You keep that in mind, and you keep searching, and you keep finding better, you're gonna be happy with what happens. I promise. You take care, you go play mapping, and I'll see you next time. Later.
Well, I look at it myself as the beginning, really, of an exploration. That's the reason we're exploring. You don't know what you'll run into on an exploration. What the sky looks like, what the stars look like. Do they still twinkle, or are they a steady light when you get outside the atmosphere?